Good afternoon. This is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So today we will start a new component, structural equation modeling. So in the last lectures we have highlighted the details about simultaneous equation modeling. So we have discussed various issues regarding a single equation modeling, and you can in the same times there is a simultaneous equation modeling. So in the case of single equation modeling there is a one-way causality, but in the case of simultaneous equation modeling there is a two-way causality, because there are interdependence of interdependence among the various variables. So single equation modeling is very easy to understand, easy to calculate or easy to estimate, whereas a simultaneous equation modeling is very complex, very confusing, or you can say very time taking component, but it is more interesting because because most of the problems, real world problems, are very interdependent in nature. As a result, it has to be discussed with an angle of simultaneous equation modeling. So without having sufficient knowledge on simultaneous equation modeling, it's very difficult to understand the real world business problems. So in brief, we have made a difference between single equation modeling and simultaneous equation modeling. So with the basic information about the simultaneous equation modeling, we have to move to structural equation modeling, because simultaneous equation modeling will give you route to the structural equation modeling. In the structural equation modeling, it is also joint dependence of variables, means existence of joint dependence among the variables, but here something there is more interesting than the simultaneous equation modeling. So before you proceed to structural equation modeling, I briefly highlight some of the issues and concepts under simultaneous equation modeling, then we will converge to structural equation modeling. So what we have discussed in the simultaneous equation modeling is that, means the objective is to describe the joint dependence among the variables. You cannot estimate the parameters of a particular single equation without having information about the parameters of other equation in the model. So now the moment you will go for simultaneous equation modeling, it basically means if you will move from single equation modeling to simultaneous equation modeling, then obviously there are two shortcomings we have to you can say overcome. So that these are, you can say, means one is a multicollinearity problem and another is a autocorrelation problem. So in the case of when we will apply means any problems using single equation modeling may have multicollinearity, may have autocorrelation, because some of the things which are interdependent we are not incorporating. But the moment when we will go for simultaneous equation modeling, so we are integrating the system in a accurate way, in a feasible way, so that the problem of multicollinearity and autocorrelation can be removed very easily. So now once you proceed to the, you can say, structural equation modeling, we will know more something more about the interdependence technique. It is one of the multivariate data analysis. So structural SEM, the popular name is called as a SEM. This is nothing but structural equation modeling. Okay, structural equation modeling. So before I go to the structural equation modeling completely, so I will slightly highlight some of the issues which we have not we have not covered details in the case of simultaneous equation modeling. So when we will go for simultaneous equation modeling, then obviously the system will be very interdependent. That means it is a problem where there are groups of dependent variables and groups of independent variables, and it's very difficult to describe sometimes who are the independent and who are the dependent, but we have to categorically classify. That is how identification problem is very important. So once you will identify properly, then obviously it is not a problem for estimation, but the problem of once you identify, then obviously the estimation will be automatically come, means accurate estimation will be perfectly come into the picture. So that is how we have to be very careful about this system, about the simultaneous equation system. So now So in the simultaneous equation system, so we have two groups of variables. One is called as endogenous cluster and another is called as exogenous clusters. So there are many ways we can express these particular problems. In fact, before this simultaneous equation modeling, we have highlighted various issues regarding simple modeling, that is cross sectional modeling, time series modeling, panel data modeling. So then then we are discussing here the simultaneous equation modeling. So now in this particular setup, so it is not in the simultaneous equation modeling. In fact, the time integration is very high. For instance, with a particular variable, we will create several dependent and independent variables with respect to lag. And this is one type of creating simultaneous equation modeling. And if it is if once you have a time lag, then obviously multicollinearity problem and autocorrelation problem is sure shot. So that is how to avoid all such problems. So we are using simultaneous equation modeling. But structural equation modeling is more advanced, more more accurate. In fact, it may not it can be applied for this type of problems, and also it is very useful for cross sectional modeling, where there are groups of independent variables and groups of dependent variables without any integration of time lag. Okay. So now if you have the time lag concept, then obviously with one, for instance, if we have xt and only yt, so this t represents time lag, and yt here also y variable with respect to time lag. So now we can create several independent variables. So this is independent variable, so this is dependent variable in the time frame, in the time being, let's say. So then we will create several independent variables, xt minus 2, xt minus 3, xt minus 3, like this it will continue. Similarly, y case yt minus 1, yt minus 2, yt minus 3, like this we can continue. Okay. So there are series of x we will create here, there are series of y you can create here. So then there is maybe sometimes yt depends upon xt, yt depends upon xt minus 1, yt depends upon xt minus 2. Similarly, yt minus 1 depends upon this one, yt minus depends y2 minus depends upon this one, so y2 minus 1 depends upon xt minus 3. This is how they are all together integrated to each other. So now before jump to structural equation modeling, I briefly find out highlight the difference about these particular structures. So basically, when we will go for time series modeling and its lag, so far as a simultaneous equation modeling system are concerned, then obviously there are two ways you have to create the simultaneous equation system. So one is called as autoregressive scheme, another is called as distributive lag schemes. So modeling, basically the time series modeling, basically divided into two parts. It's called as autoregressive models, and this is called as a distributive lag models. ARM stands for autoregressive models. Autoregressive model. Okay. Then what is autoregressive models? Autoregressive models we can write like this way: yt equal to alpha plus beta 0 xt plus beta 1 xt minus 1, okay, plus beta 2 xt minus 2, it will continue, plus beta k xt minus k plus u. Okay, ut. This is one type of autoregressive model. So then there is another model called as a distributive lag model. So distributive lag model. In fact, we have little bit highlighted this issue in the case of dynamic panel data modeling. So here yt equal to alpha plus beta xt plus gamma yt minus 1 plus ut. This is a simple model of distributive lag models. You see here. So now in the case of autoregressive models, yt depends upon exogenous variables and its lag variables. But in the case of distributive lag models, so we are taking the dependent variable, that is endogenous variable, as a function of both endogenous variable and exogenous variable, which is slightly different to autoregressive model. In the case of autoregressive models, it is the endogenous variable as a function of exogenous variable and its lag length. Okay. So the moment you will enter the lag, then obviously the additional variable will be created, and that too exogenous variable only. But in the case of distributive log models, so it is the dependent variable, and on other side it is the exogenous variables and also endogenous variables and their logs. So this is the classic difference between the autoregressive model and distributive log model. So that means we start with the yt and xt, then we will create various types of models so far as a simultaneous equation modeling system is concerned. In fact, these are all single equation systems, but we can go simultaneously with respect to you can say simultaneous equation systems. All right. So this is how we have to describe this structure of, you can say, modeling, that to distributive log models and autoregressive log models. So now these two are not so much important for structural equation modeling. In the structural equation modeling, so we are not concerned about the yt minus 1, xt minus 1, etc. Our concern is, so what are the groups of endogenous variable and what are the groups of exogenous variable. That is very important. So we have to highlight all these issues in this way. So first of all, what is structural equation modeling? So in the moment you will move into the simultaneous equation to the structural equation modeling, then obviously this particular definition is very important. Structural equation modeling, that means what is structural equation modeling? Structural equation modeling in general format is that it is the endogenous variables as a function of exogenous variables, then endogenous variables, then it's a error terms. Okay, error terms. So this is how structural equation modeling. It is the structure of various variable with respect to endo clusters and exogenous clusters. So this is the form of structural equation modeling. Okay. So similarly, in the case of there is in response to structural equation modeling, there is a concept called as a reduced form of the models. So in the case of reduced form of the models, there is called as a reduced form of the models. Reduced form of the models. Okay. So in the reduced form of the models, so your endogenous variable as a function of only exogenous variables and its error terms. Okay, and its error term. So that means we start with having a models called as a structural equation modeling. So either you have to bring proper structure and you have to find out the solutions, or else you have to transfer the structural equation modeling to the reduced form of the model. Then we can directly apply the single equation model methods to estimate the parameters. So now in the structure, what is the difference between this structural equation modeling and single equation modeling? In the case of structural equation modeling, there are obviously the model consists of at least two numbers of equations. Then there is a complete integration. So first equation depends upon second equation, or second equation depends upon first equation. So now we have to prepare in such a way, or you have to create a model in such a way, so the proper both the integration, both the equation will give you unique estimate, provide you unique estimated results. But if you are not smart enough to handle the structural equation modeling directly, so what you have to do, you have to go for reduced form of the models. So where endogenous variable as a function of pure exogenous variable and error term. So now this is the moment you will transfer the endogenous variable as a function of endogenous and exogenous error term to endogenous as a function of exogenous and error term only, then in that case, so it is just like a application of single equation modeling again. So it is not a problem. So only problem is how to transfer the structural equation modeling to a reduced form of the equation, that is single equation modeling. So that is very interesting. So the moment you are successful, then obviously it is not a problem. It is as usual single equation modeling, because the estimation process of single equation modeling is very easy to the compared to structural equation modeling and simultaneous equation modeling. So now, so either you can directly handle the structural equation modeling problems, so either with the help of simultaneous technique, or you can say structural equation technique. So now, if not, then you have to transfer into reduced form of the technique. So in the case of reduced form of the technique, so it is the system is a single in the format of single equation. Just you have to estimate the parameters by the use of any techniques like OLS, GLS, WLS, or maximum likelihood estimators. So now in response to in response to structural equation modeling and reduced form of the model, so we have a system called as a recursive systems. Okay, so there is a concept called as a recursive systems, recursive systems. Okay, recursive system is that it is the recursive system. It is, it is a chain of equations. Okay, so it is just like a structural equation modeling, but the first equation start with the endogenous variable as a function of exogenous variable only. Then second equation will be a second endogenous variable as a function of exogenous variable and first endogenous variable. Then third equation will be third endogenous variable as a function of exogenous variable and first two endogenous variable. This is how you to proceed as long as your variable in your hand. So like this, you start with like this. So y1 equal to function of x1, x2, x3 up to you can say xn, then u1. So this is first equation where endogenous variable as a function of all exogenous variable and error terms. So in the second equation, y2 equal to function of x1, x2 up to xn, okay, u1. Okay, so we put u1 error term, then first endogenous variables y1. Okay, in the second case, y3 equal to function of x1, x2, okay, xn, then u, then y1, then y2. So this is how it has to be, you can say it has to be increased subsequently. Okay, so if we will put it in explicit format, then the picture will be coming like this way. In the first equation, we will start with like this: beta 0 plus beta 1 x1 plus beta 1 x2, beta 1 x2 plus continue beta 1 n xn plus u1. Okay, similarly y2, this is y1. Okay, so y2 equal to beta 0 plus beta 1 x1 plus sorry, this is 2 1. Okay, because it starts from 2, so beta is 2, beta 2 1. Okay, so it's better you put here beta 1 0, this is beta 2 0. Okay, beta 2 0, then beta 2 1 x1, so beta 2 2 x2 plus continue beta 2n xn plus gamma 2 1 y1, gamma 2 1 y1. Okay, so then similarly it will continue. Okay, so okay, we will put another equation. Let's say y3 equal to beta 3 0, okay, beta 3 1 x1 plus beta 3 2 x2, okay, continue plus beta 3n xn plus gamma 3 1 y1, then plus gamma 3 2 y2 plus error terms. Okay, so this is how it will proceed like this way. So that means if you will put it in a matrix format, this will come like this way. So this side x1, x2, x3 up to say xk. So this side y1, y2, it will come like yn, and this is xn. Okay, xn. So this is beta 1 1. So I am just reporting the coefficient of variables only. Okay, beta 1 1. So beta 1 2, beta 1 3, then beta 1 n. Similarly beta 2 1, beta 2 2, beta 2 3, okay, beta 2 n. Okay, so beta 3 1, beta 3 2, beta 3 3, okay, beta 3 n. Okay, similarly for a first equation, these are all 0. These are all 0 here except first equation 1. Okay, in the second equation, so y2 becomes 1. Okay, and y1 becomes minus gamma 2 1. Okay, so others are remaining 0. Okay, so in the third case, it is gamma 3 1, gamma 3 minus gamma 3 2, then this is 1, then these are all 0. Okay, so this is how it is proceed. So this is another format of simultaneous equation modeling. So it's called as a recursive system. So we have a knowledge on single equation modeling, simultaneous equation modeling, structural equation modeling, and recursive systems. So with this basic setup, so we have to move to the concept called as a structural equation modeling. Okay. So first of all, what is structural equation modeling? So what is structural equation modeling? Okay, structural equation modeling has a two different setup altogether. One is called as a structural equation. Okay, another is called as a modeling. So what is modeling? So modeling is the process of presenting the real world problem as a set of mathematical equation. It is a process to transfer real world business problem in the form of a number of equation. That is what we call as a modeling. So in the first lectures we have highlight details about this modeling scenario. In the second case, structural equation, there is a dependent relationship between in the structural equations. It is the dependency relation, dependence, it's better put dependence relationship between dependent latent variables, dependent latent variables and independent latent variables. Okay, latent variables, that's right, independent latent variables. Okay, so now in the case of structural equation modeling, so we have two different setup. First is modeling and second is the structural equation. So modeling means it is the process of it is a transformation rule to transfer the real world business problem into mathematical form of the equation. In the second case, it is the structural equation. It is the dependency relationship between dependent latent variables and independent latent variables. So that means it is the question of dependent clusters and independent clusters. So I will highlight what is all these dependent cluster and independent clusters. That means we know altogether dependent variables and independent variables, but here we are discussing about dependent latent variables and independent latent variables. So that means it is something more than the structural equation modeling. So now in the structural equation modeling, there are several dependent variables, several independent variables. So we like to know how they are integrated to each other, interdependence to each others. But here structure is very important. Okay, so that's why it is called as a structural equation modeling. So the structure, so the way you will decide the structure. So in that case, so we have to use this structure called as a dependent latent variable and independent latent variable. So that means, so we have to bring a structure where we can observe the dependence, interdependence among the various variables with respect to endogenous cluster and exogenous clusters. Okay, so that means in this particular structural equation modeling, there are two sets of variables. Okay, so there are two sets of variables. So there are two sets of variables. So like simultaneous equation, we call it endogenous variable and exogenous variable. Here we will call as a manifest variables and latent variables. So here we will call it manifest variables, and another is called as a manifest variables, and another is called as a latent variables. Okay, latent variables, manifest variables, otherwise called as a measured. It is measured variables, observed, it can be observed. Okay, so this latent variables is basically hypothetical and unobserved. Okay, it is hypothetical and unobserved. Okay, so so there are two variables. One is called as a manifest variables and another is called as a latent variables. Manifest variable is nothing but measured variable or observed variable. Latent variable is nothing but hypothetical variables and unobserved variables. Means data usually available for manifest variables, then ultimately we have to create a latent variable with respect to this manifest variables. Just like in the case of time series modeling, we have yt, let's say for two variables yt and xt. So data will be available for yt and data will be available for xt, but we will create yt minus 1, yt minus 2, yt minus 3, like yt minus k. Similarly, we can create xt minus 1, xt minus 2 up to xt minus k. So within a particular system, we are creating several variables. Okay, this is one type of structure. But here the structure is that, so we have two groups of variables. So that in that time series case, it is called as a log variables. Okay, so here, so we are using manifest variables and you can say latent variable. Manifest variables, it is very much observed. Data files are there, means data are directly readily available, but in the case of latent variable, it is hypothetical and unobserved. So it is not available. So we have to construct the data file with the available data files. Okay, existing data file. That means, so we have to create something that is, it is a we have to use the processed data in a different way. That is the beauty of the structural equation modeling. So so we have to integrate means the original variables with the latent variables, so that the integration of latent variable and original variable will give you the proper structure, or you can say beautiful modeling setup. So that is how we have to discuss this concept of structural equation modeling. Altogether, this picture will be coming like this way. So endogenous variables. So basically, it is the game between endogenous variables and exogenous variable. So that means it is the dependent variables. It is the game between dependent variable, okay, and independent variables. Okay, it is the game between dependent variable and independent variables. Okay, where the variables in the models. Okay, so that means, so so we have to give a signal. So where is the dependent variable and where is the independent variable? For instance, I will give you a proper structure here. Okay, so the structure is here. I will take a simple model here. Okay, so so far as the structural equation modeling is concerned, so there are two ways we can say. There will be direct path and there will be indirect path. Okay, indirect path. So so indirect path is basically the form of pure structural equation modeling. Direct path is purely a multivariate regression modeling. It is just like pure multivariate regression modeling. Okay, before I go to highlight details about structural equation modeling, its origin and its structure, its methodology and its application. So I briefly highlight how this multivariate, it means the origin of this simultaneous equation modeling and structural equation modeling is from the multiple regression only. So it is we are handling multiple regression in a different shape altogether. So that is in the form of simultaneous equation modeling and structural equation modeling. So now I will take one simple example, how we can analyze that particular problem in the case of you can say multivariate regression modeling, and how we will put all together in the case of structural equation modeling. Let's see here, or in between, how simultaneous equation modeling can be, you can say, discuss. Okay, so the proper setup is like this. Okay, so the proper setup is like this. Let's say, so I will take two variables here. You can say let's take case of experience is one variables. Then another variable I will take it educations. Okay, then these two are, I will assume that these two are independent variables. Then here I will put it the component called as a preparedness. Okay, preparedness. Okay, there is another variables. Okay, so now simple direct path is like this. So this indicates, that means this I will call it x1, this I will call it x2, this I will call it y. Okay, so now when I will go for you can say simple direct path, then obviously I have to apply direct multivariate regression analysis, that to multiple regression analysis. So that times I will mention like this way: beta 0 plus summation beta I xi I equal to 1 to 2. So in other words, we can write like this: beta 0 equal to beta 1 x1 plus beta 2 x2 plus, you can say, error terms, alright. But in the case of this is simple structure of, this is direct path of structural equation modeling. Direct path of structural modeling is in something or nothing but regression equation modeling. Okay, it is something regression modeling only. So now, so how is it different to structural equation modeling? Let's say I will put you another diagram here, then I will highlight the structural equation modeling. So let's say same problems I will highlight here. So this is a experience, and this is educations. This is experience and this is education. Then this is risk perceptions. I will take another component called as a risk perception. Okay. Then preparedness. Okay. Okay. You see here, generally when we have a particular problem, we start with because ultimately this particular technique is also causality technique. So here the only difference is here we are having a bidirectional causality or two-way causality, or in the case on the contrary, in the case of single equation modeling, we always look for one-way causality. But here in the case of particular structural equation modeling, structure is very important. Then in the same times we look for two-way causality. For instance, we start in this particular case we have highlighted the model or problem where preparedness as a function of experience and education. Okay, preparedness as a function of experience and education. So our aim is here, means very beginning our aim is objective is how experience and education are related to preparedness, whether we will put more experience to get preparedness, or we will put more education to get more preparedness. So this is how the multiple regression can be set. But this in between, if you add any variables, or you can say subtract another variable, then the system will be completely changed. But when there is a talking of structural equation modeling, so within a particular system, so if you will add something, then it will create a structures, and then if you will form a model, so that modeling is called as a structural equation modeling. So that means within a particular system, so you have to bring a particular factor or variables. Okay, so either by natural process, or you have to create like in the form of latent variables. Okay, so now within that particular structures, so if you will integrate all together, then it is called as a structural equation modeling. Let's see how is the look of structural equation modeling. So this is how the structures. So now we have already mentioned, so experience and risk as a experience has a impact on risk perceptions, education has a impact on risk perceptions. Okay, then we have a preparedness. So preparedness we have already highlighted, there is integrations. So similarly you have to highlight here with, you can say, preparedness. Okay, experience has a impact on preparedness. Then finally risk perception has a impact on preparedness. That means you see here this picture is more slightly complicated. So you see, so we can directly write like this way. So for instance, preparedness is equal to function of experience, okay, educations and risk perceptions. We can write like this way, then you can analyze. But in that case we cannot get a particular structure, or we cannot highlight the hidden causality in between these problems. Okay, so that means, so our if we apply particular problem with means with the application of regression analysis, then obviously experience, education and risk perception should be completely independent. Okay, so that means there should not be any such linear relationship among them. But here, so we find the risk perception has a function of experience and education. So that means there is some kind of problem in between. So we have to first sort out that particular problem, then you have to go for you can say it's a solution. For instance, if I will highlight this one, if I will call it experience is x1 and education is x2, then risk perception is you can say y1. Okay, so then this is already y1, so we will call it this is y1 and this is y2. Okay, so that means here the endogenous cluster is y1 y2. Okay, so exogenous cluster will be x1 and x2. Okay, so only the thing is that only classifying endogenous variable and classifying exogenous variable will not solve your problem or will not give you any kind of solutions for this interdependence, multivariate interdependence technique. So here what is the important thing is that you have to find out the structure, hidden structures lies between these particular problems, means whatever problems we are discussing. So now here, so we like to know how endogenous means there are two specific ideas here. One specific idea or objective is to classify who are the endogenous variable and who are the exogenous variable. The second specific objective is that so we have to find out to whether there is any structure in between these variables. If there is any structure in between these variables, then you have to directly apply the structural regression modeling. If there is no such structure, then you have to go for simple multivariate regression only. If there is no structure, then obviously we will assume that these variables are completely independent to each other. So we should not go to complex problem. So it is better to solve this particular problem in a simple manner by using multiple regression analysis only. But within the multivariate the way you are solving that particular problem, so if there is any structure in between, then obviously it is better or it is suggested to use structural equation modeling rather than the you can say simple multivariate regression modeling, because if you don't understand the structure, then obviously the model accuracy will not be perfectly okay. Either it will affect the goodness fit of the models, or you can say it may affect the significance of that particular variable, that altogether the blue property will not be obtained. Okay, because we are picking up it is obvious. Of course, there is a big model which has a closed integrations, and we are just picking one equation and estimating the parameters without having sufficient knowledge. That's why at very beginning I have mentioned before you handling any statistical modeling or before you apply any statistical modeling to a particular problem, you must have a sound knowledge on theory. So theoretically you should be very sound. Where is the root of the problem, the identification of problems, the factors affecting that particular problem, means you have to identify what are the total number of factors and who are the dependent, who are the independent, whether there is any extra variables which can inserted, and whether the variables which you have chosen are all relevant variables. These are the issues you have to take care before you enter into this particular structure, particular setup of modeling. So now generally what people used to do, so they don't know all these things, simultaneous structures or structural equation modeling, etc. So they simply if you give them problems, so if you just give a clue that these are all independent variables and these are all dependent variables. Okay, sorry, only one dependent variables and these are all independent variables. So then obviously, so they will just simply apply the multiple regression, just they enter the data in the particular software, click, they will get the results. Okay, so this is not the fact here. So here, even if the problem is that we are very much keen what is the hidden agenda in that particular problem. It is not only obviously the system will be very efficient, very feasible, very practical if there are more number of variables in the systems. But more number of variables in the system means, in the one hand, it will be give you more feasibility, more practical means more practical things, but in the same times it will add lots of complexity. For instance, if you add more variables, then obviously there may be question of means there may be problem of simultaneous equation modeling, or there may be structural equation modeling. That means there may be some interdependence among the variables, because the moment you will use all these means more number of variables in a particular setup, then obviously all variables cannot be exclusively independent. So obviously there should be some kind of integrations. So if some kind of integration there and you directly apply this regression modeling, then obviously there is a standard problem is multicollinearity and autocorrelation. But if we will go indirectly, exactly knowing in the different means one's equation and how these equations are, means what are these variables and how these variables are, whether these variables are influencing with other variables or they are totally independent. If they are totally independent, then absolutely fine. If they are not means totally means they are not totally independent, then obviously there is a serious problem. So for that you have to find out a particular solution for that. Okay. So now for this particular problem, so what I will do, so I will go first, like what is we have already highlighted y1 equal to gamma 1 plus gamma 2 y, okay, plus u2 gamma 1 plus y2. But we have already highlighted this is gamma 2 y2, but we have highlighted y1 equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus u. Okay, so this is which we have highlighted with this particular setup only. Okay, sorry, means in this particular setups y equal to x1 and x2. So this is how we have cited here. This is game between, this is, if I recall y1, then it is nothing but y1 as a function of x1 and x2 only. Okay, so now it is the function of x1 and x2. So now if we will integrate this one here, then obviously this first equation is written like this way. So in the second case we are using Rick's perception. So how Rick's perceptions are integrated? So that means here Rick's perception has integration with y1. So obviously one of the standard equation we will find out here, y1 is equal to gamma 1 plus gamma 2 y2. Okay, so y2 plus u2. Okay, so then what we have to do to solve this particular problem, so we have to summarize this one. Okay, so this is obviously y2, this is obviously y2, and this is obviously y1. Okay, this is obviously y1. Okay, so if it is y1 here, all right. So now so what we have to do to solve y2, so we have to put gamma 1 plus gamma 2 into beta 0 plus beta 1 x1 plus beta 2 x2 plus u plus, let's say this is u1, this is u2. Okay, so this is u1, this is u2. Okay, so now you simplify this one. So this is gamma 1 plus gamma 2 beta 0, okay, plus gamma 2 beta 1 x1 plus gamma 2 beta 2 x2 plus gamma 2 u1 plus u2. Okay, so now what I will do, what I will say, I will see, it means the moment I will summarize, then I can write like this way, simply alpha 0 plus alpha 1 x1 plus alpha 2 x2 plus simply say error component epsilon. Okay, so now see here, alpha 0 is nothing but this particular item. Okay, similarly alpha 1 is nothing but gamma 2 beta 1, then alpha 2 is nothing but gamma 2 beta 2. Okay, so then accordingly we have to find out its solution. So this is now just like a single equation modeling, we can solve this particular problem. But this is very much okay if you understand inside the problem what is the structure hidden in this particular problem. Until unless you know the structure, you cannot sort out that particular problem, or you can say examine that particular problem. With this basic setup, so we have to proceed to this particular simultaneous, what is simultaneous equation modeling. That means our main agenda is what is this simultaneous structural equation modeling, and how this what is the root and how you have to solve this particular problems. Okay, so now structural equation modeling, basically structural equation modeling is the basic objective is to identification of structure with set of observed variables. Okay, so the basic idea about structural equation modeling is that, so you have to find out the proper structure within the observed variables. That means existing setup. So you have to find out to the structure, detect the structure is very important in the case of structural equation modeling. So detection of structures. So detection of structures. Detection of structure is one of the prime objective of structural equation modeling. So that means ultimately it is generally approach to multivariate it's a general approach to multivariate data analysis. So that means, so we can write here general approach to multivariate data analysis. Okay, so that means you see here, so structural equation modeling has two important features. So first thing, so we have discussed various aspects of econometric modeling. So then finally this is almost all one part of the problem called as a regression modeling. Then we will move to the time series modeling. In the end part of the regression modeling is the structural equation modeling. So here we have to means we are at the extreme complex environment, where we have two specific objectives. First objective is means particularly for the structural equation modeling, it is the generalization approach of multivariate data analysis. Though we have discussed multivariate data analysis in the case of with the help of multiple correlation, multiple regressions, and also simultaneous equation modeling. So similarly, in fact, simultaneous equation modeling, structural equation modeling, there are very close connections, more or less same. There is a slightly difference is there, so we will highlight what is the slight difference. But here in this structural equation modeling, so two important feature is it is a generalized approach to multivariate data analysis, and most important feature is to find out a particular structure which is usually in hidden. So you have to explore it properly, how they are integrated to each other. And another thing is that it is very difficult to find out the structure without having theoretical knowledge and sufficient knowledge about the problem. So generally, theory and problem surrounding will give you to prepare a particular structure. It's mathematically we can bring the equation, we can set the equation, but it is very difficult to set in a structure. So because various variables, how they are integrated, we cannot hypothetically just represent. We cannot hypothetically can write something. There is something available in our hand, then with the availability we have to prepare the model. So that is the beauty of the structural equation modeling. Okay, so there are various ways we can represent the structural equation modeling. It is called as a covariance analysis. It is covariance structure analysis, CSA. It is otherwise called as a CSA, covariance structure analysis. Sometimes it is called as a causal models. Okay, sometimes it is called as a causal model, and this is otherwise called as a ANOVA. Okay, analysis of variance. Okay, so then simultaneous equations. It is the question of simultaneous equations. Then there is a concept of path analysis. Then there is integration to conformatory factor analysis. Okay, then latent variable then it leads to latent variable modeling. Okay, latent variable modeling. So this latent variable modeling is nothing but the question of structural equation modeling. Okay, latent variable modeling is nothing but structural equation modeling. That means the structure is like this. So you have a dependent classification, that is endogenous variable cluster. Then you have also exogenous clusters. Okay, and that is an independent variable. So within the endogenous variable setup, so we have to find out the latent variables. So that means within the endogenous, how the one factor can be considered or factor can be created. That means it is basically integration of path model and factor models. Okay, so now you have to understand what is factor model. Actually, factor analysis is a interdependence technique through which we have to transfer the original variable to a smaller set of variables, which is a linear combination of original variables. So that is how the structure is all about. That means we have to create a latent variable which has a particular structure or integration with the original variables. Okay, so that is how it is called as a structural equation modeling. So there are many things we have to integrate here with the respect with regards to the structural equation modeling. But originally we look for two different tools here, so two different objectives. So one is the correlations and another is the causality. Okay, so that means the structure will be like this way. So the indication will be like this way: one way causality or two way causality. So these are, this is one, this is second, this is third. Okay, so these three are common agenda for this structural equation modeling. So that means, so when there is a large number of variables in the systems, and in that particular system, if you have any structure, then obviously how we have to bring that particular structure. So either the structure is a one way causality or two way causality, or there is a question of correlations. Okay, covariance. Two way causality means it's a reverse direction is not allowed in fact here, but we are calling it basically it is game between these two only, 1 and 2. Okay, so it is just we are showing that there is a question of bidirectional causality, because sometimes same variable will be affecting indirectly through other variables. Okay, so that is how, that means here we have to we discuss already correlation and covariance technique, which is the which can express the relationship between two independent variables. Okay, but in the case of causality, we have to know who causes what. Okay, so now once you find out the structure, then obviously we get to know there is some things which have causal relationship and something which have just simple relationship. So that is the correlations. Okay, so structural equation modeling, the basic framework or the basic idea is to find out the correlation issue and the regression issue. So that is the basic or major agenda for the structural equation modeling. But it is not so simple. So correlation is a very simple technique, and regression is also somewhat you can say in fact it may be little bit complex, but it is so much easy, like with respect to structural equation modeling. So correlation is easy to understand, easy to calculate. Regression is easy to understand, easy to calculate, provided you should have sound knowledge on this statistical theory. Then we have to enter to the structural equation modeling. In the case of structural equation modeling, the most important thing is you have these systems, then you have to examine the structure or detect the structure. Within the detection structures, we have to see where we have correlation and where we have a regression. So the issue of correlation and regressions with the particular setups is called as a structural equation modeling. Okay, so it is very interesting. So because it has lots of application in fact. Okay, the origin started from the psychology, then you can say psychology, then economics, then you can say biology. So it has many application in many fields in various ways. So basically the structural equation modeling is the integration of path model and factor model. So we briefly first highlight a little bit about the factor model, then we will briefly highlight the path model, then we will integrate these two to get the structural equation modeling. So we will discuss details about these setups in the next class. With this we can conclude this particular session. Have a nice day. Thank you very much.